Here are the answers for the section 13-3 homework. Number 1, expand this summation. So this symbol right here is a sigma. On the bottom, we're told to begin by substituting 2 in place of I. We're supposed to continue that until we've put in 4 for I. And then over here on the side of the sigma is the formula that you're inputting values into. So to expand this, first put in 2 where the I is. That creates a 2. Then use a plus sign because the sigma refers to summing terms together. Now put in 3 for I, and then put in 4 for I. So here's our expansion. Number 3, here's the formula 2j, and we're told to begin by putting 1 in for j. So 2 times 1 makes 2. Then put in 2 for j. 2 times 2 makes 4. Then put in 3. 2 times 3 is 6. And we're going to stop at 3 because that's the upper boundary of our summation. Number 5, here's the formula that we're going to put numbers into. We're told to begin by putting in 1 for I. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. And then number 7, substitute starting with 2 for k. 2 times 2 plus 1 is 5. Now put in 3. 2 times 3 plus 1 is 7. Now put in 4, and this makes 9. On the written assignment, we're asked to evaluate the sum. So this is a little different than expanding it. To find the answer, we're first going to expand it, but then actually add the terms together to get the sum. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Then actually add the terms together. So 3 plus 6 is 9, 9 plus 9 is 18, 18 and 12 is 30, and then plus 15 is 45. Number 3, we want to find this sum by putting in all numbers for k from 1 through 10. So 4 times 1 is 4, take away 2 makes 2. 4 times 2 is 8, take away 2 is 6. 4 times 3 is 12, take away 2 makes 10, and so on. Notice our pattern is adding 4 every time. We have an arithmetic sequence where the first term is 2 and the value of d is 4. And we want to add that together and see what the sum is. We could finish our expansion and then add all the terms together, or we could use a formula that finds the sum of an arithmetic sequence. There is a formula on page 501 of the book that will find the sum. The sum of n terms is equal to n divided by 2 times 2 times a plus n minus 1 times d. We're adding up 10 terms. We want to find the sum of 10 terms, so s sub 10. So put in 10 for n. The value of a is 2. And again, fill in 10 for n. And we figured out that the value of d was 4. Let's see what this makes. 10 divided by 2 is 5. Now what about inside the brackets? We have 4 plus 9 times 4, which is 36. So to get the answer, we have 5 times 40, which is 200. So one way to find the sum is to fully do the expansion and then add the terms together. A second and possibly faster way is to apply a formula. Number 9, find the sum of an arithmetic series when you know this information. The first term is 6, the value of d is 4, and there are 17 numbers in the list. Well, let's use the formula that we just did. If we want the sum of 17 numbers, we take 17 divided by 2, and then in a bracket, it's 2 times the value of a, plus, and then 17 take away 1 times the value of d. And then it's a matter of evaluating that expression. You can work it out in your head or on a calculator. Everything inside the bracket makes 76, and then times that by 17 over 2. The answer is 646. For number 11, we're also asked to find the sum of the series. But this time, we don't know the value of a. We don't know the number that's the first term. We do know the last term is negative 32. On page 501, there are two different formulas to find the sum, but both of them require knowing the value of a. So we're going to have to find that. Let's start by using the formula for the nth term of an arithmetic series. It's a sub n equals a plus n minus 1 times d. And since we know the last term is negative 32, and we know that there are 12 terms, that means that we know that a sub 12 is negative 32. So when n is 12, a sub 12 is negative 32. Now the only variable we don't know is a. Let's solve this out. 12 minus 1 makes 11. 11 times negative 4 is negative 44. Now add 44 to both sides. We get 12 is equal to a. Now that we know the value of a, and we know the value of L, we can use one of the formulas from page 501. It looks like this. The sum of n numbers is equal to n divided by 2 times a plus L. We want to find the sum of 12 numbers. So that's 12 divided by 2 times 12 plus negative 32. And then evaluate this on a calculator. Inside the bracket makes negative 20, and then times that by 6. The result is negative 120. Number 15. Since we know values for a, L, and the sum, let's use our formula for finding the sum that involves a and L. That formula is n divided by 2 times a plus L. And we'll make our substitutions. For s sub n, fill in 100. For the letter A, fill in 3. For the letter L, fill in 17. Notice this will allow us to figure out an answer for n, which is how many numbers are in the sequence. Times 2 to both sides, we have 200 is equal to n times 20, and divide by 20, so n is equal to 10. Knowing there are 10 numbers in the sequence will help us to figure out what the second number and the third number are. Let's create a formula for the nth term. A sub n is equal to the first term plus n minus 1 times d. And by using 10 for n, we know that that's referring to the last term, which we're told is 17. The letter A is 3. Again, we were using 10 for n. And then d becomes our unknown. When you solve this out, you'll know the answer for d. So subtract 3 from both sides. We have 14 is equal to 9d, and then divide by 9. So d is equal to 14 over 9. As a mixed number, that is 1 and 5/9. Now that we know the value of d, we can add it to this one to get the second number. It will be 4 and 5/9. And then we can add the value of d to this one to get the next answer. It'll be 6 and 1/9. For number 25, we're given a series. And notice you're adding 3 every time, so this is an arithmetic series. We're asked to write it using the summation notation, the sigma notation. Choose some variable to be your index. It's common to pick I or J or K, but you really can use any number you want to. And choose a number to start with. I'm going to count from 1 through 4 because I have 4 terms. Then we need to create a formula on the side so that we substitute values in for I, it outputs the correct value for the different terms. So if the formula was 2 times I, and you plugged in 1 for I, we would have 2 times 1 makes 2, the correct first term. But when you plug in 2 for I, 2 times 2 is 4, that's not what the second term is. So the formula is not as straightforward as just saying 2 times I. We need to find that formula. The formula that goes there is the general term formula for that sequence. So this is the same thing we've done before, where you want to write the general formula out. A sub n equals a plus n minus 1 times d. So the general term is equal to the first term plus n minus 1 times 3. Now let's simplify this side right here. This becomes 2 plus 3n minus 3, which makes 3n minus 1. That's the general formula. But I didn't choose the letter n. I could have. I chose I. So my formula is 3i minus 1. Now when we test it out, it'll output the correct numbers. Put in a 1. 3 times 1 is 3. Take away 1 does make 2. Now put in a 2. 3 times 2 is 6. Take away 1 does make 5. Page 497, number 4. We're asked to write out the first 4 terms of the series. So we have negative 3, comma, and then d is negative 3, so it means to subtract 3 each time. So this is negative 6, negative 9, negative 12. Next, number 10. Given this information, find out what the 5th number would be. So let's use our general formula. A sub 5 is equal to the first term plus 5 minus 1 times d. 5 minus 1 is 4. 4 times 3 is 12. Negative 2 plus 12 is 10. The 5th number is 10. Number 18. Given some of the numbers in the sequence, find what the 35th number would be. Well, we know the value of a. It's the square root of 2 plus 1. Let's look from term to term and figure out what d is. What's happening to go from this to this? Looks like you're subtracting 1. Then to go from this one to this, it looks like you're subtracting 1. So we know the first term and we know the d. This is just like the last question. A sub 35 equals the value of a plus, and then 35 take away 1 times the value of d. Then simplify this. So this is the square root of 2 plus 1, and then 35 minus 1 is 34. 34 times negative 1 is negative 34. So our answer is the square root of 2 minus 33.